All right, this video is in two short parts. Here's the first part. Last time we thought about location, and location is an example of a vector. A vector is any quantity that has two characteristics to it, both a direction and a magnitude. By magnitude, we mean size, how much, how big, and how many. When you use those kinds of words, what comes to mind are always positive numbers. The amount of stuff, how much, how long, how far. Magnitude, in other words, is always a positive number. Important thing to remember. People get confused by that every once in a while. So we're talking about motion, which is change in location. And we have a standard way of talking about change in any quantity, change over time for any quantity. We write it like this, Greek letter delta times, or Greek letter delta followed by the quantity that's changing. And we read this as change in this case, location. And change in anything we always think of in the same way, always, final value minus initial value. That is, in this case, we're watching something move around, and at the initial moment when we first start watching it, here's its location, the initial location, and later on when we're finished watching it, at the end of its motion, it's at the final location, and XF represents the final location. But this is motion that happens during some time interval. This is the location at the beginning. This is the location at the end of the time interval. So just for one example, in one-dimensional motion, something moving back and forth across along some straight line, if the initial location is here at minus 3 meters, the initial location vector is minus 3 meters, where the direction is represented by the sign, which means in order to get to this point, if you're starting at the origin of the coordinate system, you have to move in the negative direction. So minus 3 meters is the initial location, and just imagine a bug walking back and forth along this line, and eventually it ends up here at the final location, plus 4 meters. So put those two numbers into the formula. Final location of 4 meters minus initial location of minus 3 meters. So that's 4 minus minus 3, or 4 plus 3, plus 7 meters. Since the change in location is built out of two vectors, change in location is itself a vector, so it has both size and direction. And again, direction is indicated by the sign. Size is just the absolute value. So in this case, a positive sign means the change in location was in the positive direction. To get from the starting point to the finishing point, you moved in the positive direction. Or the final location was a more positive number than the initial location. Those are all three equivalent ways of describing it. The change in location vector points in the positive direction. And the magnitude, the absolute value, is just 7 meters. What that means is that the distance between the starting point and the finishing point is 7 meters. The magnitude of a change of location vector is always equal to the distance between the start and the finish. One more example. let's say our little bug starts out at an initial location here, minus 2 meters. And let's say the final location is just here. Final location is minus 1 meter. So the distance between the starting point and the finishing point is a distance of only 1 meter. In other words, the magnitude of the change of location vector is just 1 meter. But imagine there are many different paths, many different trips that bug can take in order to get from the starting point to the finishing point. The bug might start here and then move this way all the way to the plus 2 meter point, and then come back and end at x equal minus 1, or the bug might just move directly from minus 2 meters to minus 1 meter. And we'll call this longer path, path 1. And the short path, directly from minus 2 to minus 1, we'll call that path 2. As far as change in location is concerned, those two paths amount to the same thing, because for both path 1 and path 2, the initial location is minus 2 meters, and for both of them, the final location is minus 1 meter. So for both of them, the change in location vector, which by the way we also call the displacement vector, for both of those cases, final location is minus 1 meter minus the initial location, which was minus 2, minus 2 meters. So that gives us minus 1 plus 2 meters, or plus 1 meter. That is the change in location vector. The displacement vector points in the positive direction. In other words, when this change in location happened, the final location was more positive than the initial location. The bug moved in the positive direction. To get from the start to the finish, you have to move in the positive direction. And the magnitude is 1, indicating that the starting point and the ending point are just 1 meter away. But the displacement is the same for both path 1 and path 2, even though the total distance traveled for path 2 is much longer. The total distance traveled for path 1 is much larger. The total distance traveled for path 2 is just 1 meter. But the total distance traveled for path 1 is what? Here's 2 meters and then another 2 meters. So we get from here to here, the bug travels 4 meters. And then to go from here to here, the bug travels another 3 meters. Total distance traveled along that path is 7 meters, very different from this path, and yet the displacements are the same, because the displacements depend only on where you end up and where you start. They don't depend at all on what happened in between the start and finish. The moral of the story is that a change of location vector or displacement vector tells you only the net result of all the movement that took place between the start and the finish. There was a lot of movement in path 1. There was a lot of movement in the positive direction plus a lot of movement in the negative direction, but the net result was only a movement of 1 meter in the positive direction. Okay, that's all for part 1, and part 2 comes right after this.